Welcome, dear students, to this third lecture of unit number 4. In the second lecture, we have seen that there are 14 Bravais lattices, then coordination number, that is the number of equidistant nearest neighboring atoms to a particular atom which are in direct contact with each other, and for the 3 cubic system or 3 cubic crystals we have seen it. For simple cubic, the coordination number is 6. For body-centered cubic structure, it is 8. And for a face-centered cubic structure, it is 12. Next was the atomic radius, that is half the distance between any two nearest neighboring atoms which have direct contact with each other. For a simple cubic structure, this atomic radius r is equal to a by 2, and for body-centered cubic crystal, r is equal to root 3 a by 4. Now next we will see the atomic radius for face-centered cubic crystal. In face-centered cubic structure, each corner atom touches the face-centered atom along the diagonal of the face of the cube. See in the figure, we are observing that this is the face-centered atom and it is touching these corner atoms along this diagonal. Okay. So, from figure, AC square is equal to AB square plus BC square, where AB and BC are the edge length. Therefore, AC square is equal to A square plus A square. Therefore, AC square is equal to 2A square, or AC is equal to A root 2. If we see the figure, AC is equal to 4R, that is, this is R, this is also R, and this is 2R. AC is equal to 4R. If we substitute these values in equation 1, we get 4R, that is AC square, is equal to A square plus AB square plus BC square, and this AB square plus BC square is nothing but 4R, that is equal to A root 2, and therefore R is equal to A root 2 by 4. Okay. Next is the atomic packing fraction or packing density. It is the ratio of volume occupied by total number of atoms per unit cell. As this number, that is the total number of atoms per unit cell, varies from structure to structure, and so the atomic packing fraction or packing density will also vary. Then what is this atomic packing fraction? It is the ratio of volume occupied by total number of atoms per unit cell to that of total volume occupied by the unit cell. That is number of atoms per unit cell multiplied by volume of each atom divided by volume of the unit cell. As we know, atom has a spherical shape, and therefore the volume of each atom will be 4/3 pi r cube, and therefore atomic packing fraction is equal to N, that is number of atoms per unit cell, multiplied by V, that is volume of each atom, and divided by capital V, that is volume of the unit cell, or that is equal to N into 4 by 3 pi r cube, that is the volume of sphere, and upon A cube, where A is the edge length and unit cell has a cubic structure or cubic shape. Therefore, its volume is cube of side, where N is the number of atoms per unit cell, small v volume of atom, r radius of atom, small a side of unit cell, and capital V volume of unit cell. For simple cubic structure, what we know that the number of atoms per unit cell is 1. Then volume of one atom is equal to 4/3 pi r cube. Side of unit cell A, therefore volume of unit cell is equal to A cube. Then substituting these values in the formula or definition of atomic packing fraction or packing density, we get small n, that is 1 into 4/3 pi r cube divided by A cube. Now, for simple cubic structure, R is equal to A by 2 or A is equal to 2R. Therefore, replace this R A by 2R, and the cube of 2R is 8R cube. Then this R cube gets cancelled and we are left with APF, that is atomic packing fraction, is equal to pi by 6. Substitute the value of pi as 3.142 or 22 by 7. We get atomic packing fraction for simple cubic structure or simple cubic crystal as 0.52. In the same way, we will see the atomic packing fraction for body-centered cubic structure. In this case, the number of atoms per unit cell are 2. Therefore, volume of atom is equal to 2 into 4/3 pi r cube. Side of unit cell is equal to A, and that is equal to 4 by root 3 R. Volume of unit cell A cube. And then atomic packing fraction is equal to 2 into 4/3 pi r cube divided by A cube. Substitute the value of A from above, that is 4 by root 3 R. We get APF, that is atomic packing fraction, is equal to 2 into 4 by 3 pi r cube upon 4 by root 3 R, its cube. And when all the things get cancelled, we are left with root 3 pi by 8, and its answer comes to be 0.68. Next is the atomic packing fraction for face-centered cubic structure. In this case, the number of atoms per unit cell are 4, and therefore volume of one atom is equal to 4 into 4 by 3 pi r cube. But from the previous lecture we know that side of unit cell in case of FCC is A is equal to 4 by root 2 R and volume of unit cell is equal to A cube. Substituting all these values, we get atomic packing fraction for FCC is equal to 4 into 4/3 pi r cube upon 4 upon root 2 r its cube. Cancelling the equal terms, we get root 2 pi by 6, or that is equal to 0.74. Therefore, the atomic packing fraction for face-centered cubic structure is 0.74.